Okay, welcome back. I have worked out a similar problem in week 8 at the start of week 8 videos. This is pertaining to dilution. Okay, I'm just coming back and revisiting this topic just one more time, just to make sure people that don't understand the previous time, hopefully this time I may have said things differently that might help you understand. All right. Now it's asking, as with any other questions I've worked for you, first figure out what is the question wants you to do. How much water? Water is a liquid. Unless it's an ice, then it becomes solid. Otherwise, it's liquid. So it's asking you to find the volume, which could be in mils or liters, doesn't matter. Okay, we can figure that out specifically which one as we read the question further. Would be needed to add it to a, now as I've repeatedly said, okay, no matter how much layman terms I've used to help you understand a concept, certain things I cannot even avoid myself do it, which is write things a certain way, right? Now, if you speak to anybody that writes a chemistry problem, they write certain things a certain way, okay? So I don't know why the mil's appearing twice here, but I'm saying 500 mils of a 2.8 molar sodium chloride solution, right? This is a certain way of just doing certain things. That means this is what you're starting with, and so you're starting with, this is the concentration, this is the volume. So I've come up with the formula. I did not come up with the formula. I've written it in this way, which is concentration at start. I've just slightly modified to fit the needs of my students. I did not come up with this concept. So concentration at start, volume at start, concentration at the end, volume at the end. For everything in life, there's a start and an end. Okay, there's nothing called infinity in life or nature. Infinity only appears in mathematics. Okay, there's no such thing as infinite in life. Everything has to start, everything has to end. Okay. So when I write this way, that means I know the concentration at the start, which is 2.8 molar. So I know the concentration at the start, and I know the volume at start, which is 500 mils. Okay. And I'm asking you, and I know the end concentration, which is C end. Okay. But how much water would be needed to add it to a 500 mils, okay? So this is not a straightforward plug-in jug. You have to do one another modification to it when you're finished with the problem, okay? But let's start it this way first. So we know concentration at start is 2.8 molar times, at the start I have 500 mils, right? We have to find the total volume, okay? Not how much water we will add. This is just the total volume. So concentration at the end is 0.5 molar and volume at the end. The volume at the end corresponds to the total volume, okay? I will also show this pictorially once I finish with the problem. So basically, you're trying to find Vn. So that would be 2.8 times 500 divided by 0.5. So the V end is the total volume, okay? V end equals, it was 2,800 mils. You do not have to do anything. Unless the question specifically asks you for liters, then you don't need to do any conversion. So basically what I did is 2.8 times 500 over 0.5, okay? That'll give you Vn. But is the question asking for the total volume, or how much do you need to add to the existing 500 mils to make it to 2,800? So to actually find the volume, I'm going to call it V dilution. What that means is you have to take your V end and you have to subtract the V start from the V end, okay? That is 2,800 mils minus 500 mils. equals 2300 mils. This is the answer. Chances are most of you would plug and chug and stop right here, and that is not right. This is where your problem is complete. So what is really happening here is, I'm going to show this pictorially, okay? So let me get my colors. So at the start, say you have, 500 mils. I'm going to say all this is 500 mils of 2.8 molar, okay? Every drop of this 500 mils is 2.8. And the question is asking, I'm going to get a different color here. When you're finished with your dilution, your final concentration has to be 0.5 molar. And the question is asking, how much water would you add to this empty space so that the total volume is, which we now know is 2800. We don't know that also when we start, but conceptually what you're really looking at is how much water would you add into this space right here. So this is your glass container. It already has 500 mils of water. You cannot add 2800 to it to make it 3300, okay? I know what your mind is thinking. Should I add the 500 to make it 3300? No. 2800 is where you will end up with. So this is 2800. So that means I must have only added 2300 here to the existing 500 to make it 2800. That's exactly what I have done here. Okay. So how much water means you do have to come back and figure this out. All right. Now, let's say I modify this question as what is the final concentration? Okay. Okay. What is the final concentration? Okay. When 2.8 molar sodium chloride, that is 500 mil, is diluted to 2800 mils. Let's say the question appears this way. Okay, this is much more easier because you do not have to do this final conversion here. You just have to start with this step right here. Let me do the problem. So V start times C start equals V end dot Cn. Okay. So V start is 500 mils. C start is 2.8 molar. V end is 2800 mils, and C end is what we have to calculate because it's asking for final concentration. So if you do 500 times 2.8 by 2800, you will get 0.5 molar. Mils cancel out, so you get molar. Now, here you do not have to do anything else. You can just stop with the conversion. It's when it is asking for final concentration, you stop here. When it's asking for actually how much water is needed, you do the subtraction step. All right, I think these are the 4 particular areas that most of you have requested a little bit more help, maybe re-explaining the same concept. So I have done that. So I'm going to post these, and then if you have questions, please do ask me. Otherwise, that's a wrap of that material. All right, stay tuned.